Yes, class 10th student from ICSE board. Now we are going to start your first chapter, linear inequalities. So before starting this first chapter, now I am going to discuss about mathematical symbol, which is very important for you in this chapter. So mathematical symbols, some mathematical symbol which is very important for you. For example, n. N represent set of natural number. What? Set of natural number. Z means set of integers. R means set of real numbers. Q represents set of rationals, means set of rational number. And Q complement or QC or R minus C, this represents set of irrationals, means set of irrational numbers. Sometimes we are using R positive. R positive means set of positive real numbers. And same manner, Z positive is set of positive integers. These are the mathematical symbol of the representation of set. Now, this symbol, the curly bracket from both sides, this represent set, and this symbol represent belongs to, and one side arrow, this symbol represent implies that, and from both side arrow, this symbol will represent implies and implies that, and this two dot represent such that, and this symbol represent for every or for all, and this three dots, one dot above and two dot below, this represent therefore, and two dot above, one dot below, this symbol represent since. And now we are coming the most important symbol, this symbol. This is your first symbol for inequality, and this symbol is called less than or equal to. Now reverse this symbol. So this symbol is called greater than or equal to. So these are the basic symbol which we will use in this chapter. Now I am coming on the last two symbols. First symbol was less than or is equal to. It's your first symbol of linear inequality. Why this is inequality? Because it includes equality as well as less than. That is why this symbol is called unequal symbol or inequality. So this symbol is less than or equal to. Now let I am taking example. Let x is less than or equal to 10. It means the value of x either equal to 10 or less than 10. Value of x either equal or less than 10. If it is not given that x where belongs, means x is either rational or irrational or integer. If this is not given, then we must assume that x must be real. So x is the real, and it is less than or is equal to 10, means maximum or greatest value of x is 10. Now let's suppose I am representing this inequality x less than or is equal to 10 on a real line, and I am assuming that x are real. So if x belongs to real number, then x less than or is equal to 10 represent on real line or number line. Represent on real line or number line. Represent on number line. So first we should draw a real line, and let here is the 0. So from left to the 0 or negative real number lies, and from right to the 0 or all positive real number will lie. Now it is given that x less than or is equal to 10. Let's suppose this number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let this is 10. So all real number which is less than or is equal to 10 means if we represent on real line, so all real number which is less than or is equal to 10 means all this area will be included. X less than or is equal to 10 means 10 must be included. So all the real number less than or is equal to 10. So this is the representation on real line or number line. Now let's suppose x less than or is equal to 10. Let x less than or is equal to 10 and x belongs to integer. So represent this on number line. Represent on number line. Yes. So how we can represent it on number line? Let x less than or is equal to z and x is integer. So first we draw a real line, number line. Let this is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So x, let this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and so this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So x is less than or is equal to 10 and x are integer. So the greatest value of x is 10 and after that 9, because maximum value of x is 10 and next integer is 8, next integer is 7, 6, 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and so on. So the solution set becomes, here the solution set becomes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, minus 1, and so on. So this is the solution set of x less than or is equal to 10 and x is the integer. Now we are coming another inequality which is very important, greater than or is equal to, greater than or equal to. Now x great, let any number x greater than or is equal to 10. So it implies that the minimum value of x is 10. The minimum value of x is 10. That is either x is equal to 10 or greater than 10. So let x belongs to z. So it implies that all the integers greater than or equal to 10 means the solution set becomes 10, 11, 12, 13, 14, and so on. So this is the solution set if x belongs to z. So 10, 11, 12, 13, 14, and so on. x belongs to z, then x greater than or is equal to 10 represent on number line. So first we should draw a number line. Let this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on. So x greater than or is equal to 10 and x are integer. So in the solution set, x will be 10, 11, 12, 13, 14, 15, 16, 17, and so on. So it's a representation on number line of the inequality x greater than or is equal to 10 and x belongs to integer. So here the least value of x, is 10 and all other values are greater than 10 but must be integer. Now if x belongs to real number and x greater than or is equal to 10, then represent on number line. So first we should draw a real line, number line. Let this is 0, 1, and so on. Let this is 10, and all the real number greater than or is equal to 10 means included all the number greater than which lies on the number line. So this all region will be included. X greater than or is equal to 10. Here minimum real value of x is 10 and all other values are greater than 10 which represent on number line. So this is the representation on number line. So it's your basic concept of inequality. Two types of inequality. First, less than or is equal to, and second, greater than or is equal to. Now we are coming on interval. So in this chapter, two types of interval. First one is closed, second one is open. So closed interval and open interval, and its other sub part, or simply we say that sub kind, will be semi open or semi closed. Let x belongs to big bracket from left A to B. So big bracket from left and big bracket from right. So it represents the closed interval from left and closed interval from right. So all the real number which lies from A to B, it implies that all the real number which is greater than or is equal to A and less than or is equal to B, and x belongs to real. So this is the closed interval, means x starts from A and end at B. The minimum value of x is A and the maximum value of x is B. Now on the real line, on the number line, let this is A, this is B. So x starts from A up to B, and on the number line, this whole region belongs to this interval. X belongs to A to B. So it's your closed interval, closed from left as well as closed from right. This big interval, this big bracket represent closed interval, means included A and included B, and all the real numbers lies between A and B. So it's a closed interval. interval. Now, open interval. Open interval means let x belongs to a to b, and from both sides a small bracket put. From both sides we put the small bracket. So this represents that all real number lies between a and b, means x is strictly greater than a and strictly less than b. X is strictly greater than a and strictly less than b, means the real number which is greater than a and less than b. Let this is a, this is b on the number line. So all the number lies between a to b, means a must be excluded as well as b excluded, and all the real number lies between a and b. So it's your representation on the number line of this open interval. Now I am taking some examples. So, closed interval 2 to 3 means all the real number greater than or is equal to 2 and less than or is equal to 3. All real number means x belongs to real number. So how can you represent on number line? Let this is 2, this is 3. So included 2, included 3, and include all the number lies between 2 and 3. So it's your region on the number line. Now let's suppose open interval 2 to 3. So it implies that x is greater than 2 and less than 3, means excluded 2 as well as excluded 3, but all number must lies between 2 to 3 and all are real. So on the number line, let this is 2, this is 3, 2, 3, no, 2 is excluded, so 2 we could not take. So all the number lies between 2 to 3, means x starts beyond the 2, just beyond the 2, and end just beyond the 3. So it's the representation on number line. Now I am coming on sub kind of interval, means semi open or semi closed interval. Semi open or semi closed interval. Let x belongs to closed from left but open from right. So because it's closed from one side and open from one side, so this is called semi open or semi closed. So it implies that x is greater than or is equal to a but is strictly less than b, and x belongs to real number. All x must be real, and let x belongs to open A to closed B, means from one side open and another side closed. So it implies that x is greater than A but less than or is equal to B, means x start just beyond the A and end at B, and x must be real. So, अगर आप तो इसको want to represent on real line, let this is A, this is B, and x greater than or is equal to A means x must be included, A must be included, and B must be excluded, and all the number line between A and B. Now for this semi-open interval or semi-closed interval, from A to B, from left side it is open, means A you can't take, means number starts just after A and up to B, B must be included. So all the real number greater than A and up to B, it's your representation on number line. Yes, student. So I am coming over Next concept of inequality. If A is less than or is equal to B, so it says that either A less than B or A equal B. And if A less than B and B less than C, so it implies that A less than C. Next, if A less than B and C less than D, so it implies that A plus C is less than B plus D. If we multiply or divide, the inequality by a positive number, if we multiply or divide any inequality by a positive number, then inequality remains unchanged. Inequality remain unchanged. Example, let A is less than B and n is any positive real number. Then NA is less than NB or A by N is less than B by N. Here I am dividing by a real number N, which is positive. Here I am multiplying by a real number N. It is positive. So inequality remains unchanged. Now I am taking some particular example. Let I am taking example 2 less than 3. So it implies that if we multiply 2 by 4, so it must be less than 3 multiplied by 4. Here I am multiplying by a positive number. 2 4s are 8, 3 4s are 12. So it implies that 8 is less than 12. Now let I am dividing by 4. So 2 by 4 is less than 3 by 4 because 4 is positive. So inequality remains unchanged. But if we multiply or divide by a negative number, negative real, then inequality gets reverse. Yeah, inequality becomes reverse. For example, let A is less than B and N is negative real. Then NA is greater than NB or A by N is greater than B by N. Here I am multiplying by N is the negative real number. And here I am dividing by a negative real number N. So inequality becomes reverse. Now I am taking some particular example. You know that 5. Let I am taking minus 5, not 5. Minus 5 is greater than minus 8. Let I am taking a negative real number. N is equal to minus 2, which is the negative real number. So if minus 5 multiplied by minus 2 and minus 8 multiplied by minus 2, so inequality becomes reverse. And minus 5 into minus 2 is 10 is less than 16. Let I am dividing by minus 2. So minus 5 by 2, minus 5 by minus 2 and minus 8 by minus 2. So inequality gets reversed, inequality becomes reversed, and minus 5 by minus 2, it is 2.5, and 2.5 is less than 4. So it's your some particular examples. Now, I am coming on next rule. If A is less than B, so I'm taking some same exponent of A and B to the both sides. So it implies that A power R is less than B power R if R is positive. If you are taking a positive real number, then inequality becomes unchanged, means less inequality will be less. And if A is less than B, so it implies that A power R is greater than B power R if R is negative. It's your most important rule of inequality. Let I am taking some example. 2 is less than 3, and let R is 5. So 2 power 5 is less than 3 power 5. And let I am taking R negative. Another example. 5 is less than 15, and I'm taking R is minus 2. So 5 power minus 2 is greater than 15 power minus 2. Why? Because 5 power minus 2 is 1 by 5 power 2, and it is greater than 1 upon 15 to the power 2. So it implies that 1 upon 25 is greater than 1 upon 15 square is 225. Now I am coming on next rule. If A is greater than B, so it implies that minus A is less than minus B. Minus A is less than minus B. For some particular example, 3 is greater than 2, but minus 3 is less than minus 2. Next rule. If A is less than B, so reciprocal of A is greater than reciprocal of B. But this is applicable when A and B are of same sign. A and B are of same sign. If A is negative, then B must be negative. Means if A is less than B and both are positive, greater than 0. So it implies that 1 upon A is greater than 1 upon B. And let A is less than B and it is less than 0. Both are negative. So it also implies that 1 upon A is greater than 1 upon B. So A and B must be same sign. Now I am coming on next concept. So your next concept is very important for you. X plus 1 upon x is always greater than r is equal to 2 for every x positive. For every x positive. And x plus 1 upon x is less than r is equal to minus 2 for every x is negative. Some particular examples. Let x is any number. I am taking x is 5. Because x is positive, so x plus 1 upon x becomes 5 plus 1 upon 5. And it is greater than r is equal to 2. Now I am taking x is 0.1. So it implies that 0.1 plus 1 upon 0.1. So it is 10.1 and it is greater than r is equal to 2. Let I am taking x in negative real number minus 0.1. So x plus 1 upon x becomes minus 0.1 and minus 1 upon 0.1. So it is minus 10.1 and which is less than or is equal to minus 2. Means here its minimum value is 2. This represents minimum value of x plus 1 upon x is 2 when x is positive, and this represents maximum value of x plus 1 upon x is minus 2 and when x is negative. Next, I am coming on a very important topic, modulus function. Modulus function, which is very important for the topic linear inequality. Modulus function means absolute value function or magnitude function. It always gives the magnitude. So fx is equal to modulus of x. So modulus of x, it will be x if x is non-negative and minus x if x is negative. For example, I am taking x is minus 2. So if x is minus 2, so x is minus 2 means you will get this result minus of x, because here x is negative. X is negative inside the modulus. So your answer becomes minus of minus 2. So it is always greater than or is equal to 0. So that is why modulus function is called absolute value function or magnitude function. Now, its graph will be y. Fx is y. So y is equal to x when x is greater than or is equal to 0. So you will get this portion of the graph, y is equal to x when x greater than or is equal to 0, and this line is y is equal to minus x, but it exists only for x is less than 0. So it's your graph. Its line, this line is y is equal to x, and this line is y is equal to minus x. It is symmetric about y-axis. This is x-axis, and it is lies above the y-axis, above the x-axis. Means above the x-axis means its graph lies either in first quadrant or in second quadrant, and in both quadrant ordinate must be positive. So f y ordinate means y and y means mod x. So mod x is always greater than or is equal to 0. So modulus of any number, any function is always non-negative. But mod of x into y is equal to mod x into mod y, and mod of x upon y, this is equal to mod x upon mod y, and mod x is always greater than or is equal to 0. Next property, if mod x is less than or is equal to a and a is a positive number, then x lies between minus a to a. X lies between minus a to a. And if mod x is greater than or is equal to a and a is positive, then x is less than or is equal to minus a, or x is greater than or is equal to a. It's a very important property of modulus function.